Okay, welcome to today's lesson on graphing stretches and shrinks in our transformations unit. So today we're going to put together all of our pieces, adding in the graphing portion, working with that stretch and shrink horizontally and vertically. Okay, now going back to our last lesson, okay, we want to remember some of our basic rules. Vertical operations, vertical stretch and shrinks are on the outside of the parent function. If we see a value greater than 1, that will be a stretch vertically. If we see a value between 0 and 1, that will be a shrink vertically. Our horizontal transformations are always on the inside, and we have to remember that it's an inverse operation. Any value fractionally between 0 and 1 will be a horizontal stretch. Any value over 1 will be that horizontal shrink. So you're going to do the inverse operation. Just a reminder of our basic rules. Okay, everything that we see in transformations follows the High-Vol rule. Horizontals inside, verticals outside. Okay, and then we also have our head shake. The horizontal head shake tells us that we don't trust what we see. We want to do an inverse operation. The vertical head shake up and down tells us that we do trust what we see, and we apply the operation as given to us. Okay, so now when we're looking at our graphing, first thing that we want to do is identify the parent function. If there's no parentheses, remember to group the parentheses right around the x value. So we can rewrite this as 3 parentheses x squared. So we can see now that the 3 is on the outside. Outsides are vertical. Head shake rule tells us we trust what we see. So this is going to be a vertical stretch by a factor of 3. Okay, or we also want to remember everything vertically is affecting our y values. So the y values are going to be multiplied by 3. Now, in order to do the graphing, we want to start with the original parent function, x squared. Our original parent function points, -2, -1, 0, 1, 2. For the x squared, we only need 5. There will be one of our functions where we will need 6 parent points. But then as we run these x's through our function, we get 4, 1, 0, 1, and 4. So those are the original parent points for the x squared graph. Now, for our transformation of this graph, okay, we want to apply our rule, y times 3. So the x values do not change. There's no horizontal adjustment within this function. But then every one of our y values is going to be multiplied by 3 to show that horizontal stretching, vertical stretching of the value. So now, once we have our transformed graph, we put it on the coordinate axes, 0, 0, -1, 3, +1, 3, -2, 12. Goes off the graph a little bit, but that's okay. And then +2, 12. Okay, make sure that with the x squared, you're rounding your graph slightly, okay, as we work through and draw those points. Okay, so when you're working in Schoology, the one thing you're going to be doing is you're going to be inputting this transformed table. Okay, so we want to be able to work off of the graph paper, but then we're inputting our data points to show that we can algebraically transform the equation. Now, next graph here, new parent function. Our parent function is the square root of x. Okay, values, we want to work with perfect squares. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. Okay, so those are our original values overall. And in a lot of cases, we won't be able to fit this one on the graph. We might in this case. Okay, so if it does fit on a normal coordinate axis, we would want to apply that to our graph. So now the square root, we can see this is our parent function. We've got a multiplier on the outside of a 1/2. Okay, so it is a vertical transformation because it is on the outside. 1/2, we trust what we see. If we multiply by 1/2, it's going to vertically shrink by the factor of 1/2. Okay, so once again, our x values are not adjusted at all. So we keep our x values as is. And for our vertical adjustment, all of our y values are going to be multiplied by 1/2. And then once we have our transformed points, then we put those on the graph to show our process. And then we sketch through. Okay, that square root graph starts at that original point. Okay, it doesn't go in both directions. Okay, it has that one starting point and always goes in one direction. Okay, now working with some inside operations, we can see the 3 is inside the parent function, or the parentheses. Insides are horizontal. Horizontals, we don't trust what we see. So this is going to be a horizontal. Instead of a stretch, which would multiply by 3 would be a stretch, this is going to be a horizontal shrink by, and then we always look at the reciprocal value. Horizontal shrink by 1/3. So working with our original parent function points, that's always our starting spot for the parent function of x squared. The next thing we do is we just take all of our x values and multiply by 1/3 or divide by 3. Okay, these are going to be a little bit tougher to graph, but you want to estimate them as best as possible. When you're inputting into Schoology, if your fraction does not end perfectly, type it in as a fraction. So you would type this in as 2 divided by 3 instead of the rounded decimal value 0.667. Okay, no vertical transformation in this case. So what we're going to see here is we're going to see a horizontal shrinking. The graph is really going to compact from side to side around that 0, 0 coordinate point. So -1/3 1, -2/3 4. So we've got a tough compaction in this case. And once again, when you're putting the points on the graph, you just want to graph them as accurately as you can. Okay, when we're dealing with thirds, it is a little bit of a more difficult operation. Okay, another horizontal operation. We've got the divided by 3 on the inside. Okay, remember that head shake rule. We're not going to trust what we see there. So this is actually going to be a horizontal stretch by a factor of 3. Okay, so it's always on the inside. You're doing an inverse operation. Starting with our original parent values for the square root graph. Okay, horizontal stretch by 3. We're multiplying all of our x values by 3. Okay, remember, your description and what you do mathematically will match. They just won't match what you see in the equation. Okay, you can see some of these points aren't going to fit on the graph normally. Okay, so we do want to adjust for that when we're putting it on our coordinate grid. So we've got 0, 0, 3, 1, and 12, 2. That 12, 2 is off the graph just a little bit. Okay, but if it's close enough, we definitely want to put it in as a part of the graph overall. Okay, now, this last example, we're going to throw in a bunch of other operations. Okay, we've got some reflections, we've got some stretches and shrinks, and we'll talk through the process of what you do when you see multiple operations. So on the outside, we've got 2 pieces. Okay, we have a vertical reflection. Okay, with the vertical reflection, we also have a vertical stretch by 3. We trust what we see on the outside. On the inside, we've got a horizontal reflection. And then we also have a horizontal multiplier. We don't trust what we see, so this will be a horizontal shrink by a factor of 2. And then the last piece that we have is outside of the square root. You always want to see where the square root ends. Okay, we've got an up 6 adjustment. Outsides are vertical. We trust what we see with that vertical head shake. So now we've got a lot of operations. We always want to go back to the original parent function and start from there. So 0, 0, 1, 1, 4, 2, and 9, 3. Now when it comes to your vertical reflections, vertical stretches and shrinks, horizontal reflection, horizontal stretch and shrink, those are always easiest to do on the table itself. So let's start with our horizontals. Horizontal shrink by 2. So I'm going to have to divide all my x values by 2, but then we also have that negative applied. Okay, the opposite of multiplying by -1 is dividing by -1. Okay, so all we're doing is changing signs and dividing by 2. So we've got a -1/2, 4 times a -4 divided by 2, -2. We got -9 divided by 2, -9/2, or -4.5. You know, when it's a perfect decimal like that, you can include it. Now we've got our vertical transformations. We've got a vertical reflection, so all of our y values are going to be multiplied by a -1. Okay, vertical stretch by 3, so that 0 still stays 0, but we have a -1 times 3, -3. 2 times a -3, -6. 3 times a -3, -9. Okay, now we've got one last piece though. Our y value isn't completely finished. The up 6 you can do in either position. You can move it once it's on the graph, or we can do the transformation overall. So we need to add 6 to all of our values to finish out our table in this case. Okay, so now we finally have our transform points that we can put on the graph. We've got 0, 6 as our first point, -1/2, 3, -2, 0, and -9/2, -4.5. So 4.5, and that should be a -3. So you can see the graph definitely looks a lot different. Okay, when we have a reflection applied to it, in this case we've got a double reflection, horizontal stretch, vertical stretch. So we do have those pieces being applied overall. Okay, and then the last piece we have here is just a reminder of what we see operationally when we do our shifts. So looking at how it shifts a graph, and outside plus is up and outside minus is down. Okay, remember that inside we don't trust with that horizontal head shape. So a plus is left and a minus is right. We have to do the opposite. Okay, our reflections are nice. We have that -1 multiplier. Outside is a vertical reflection, inside is a horizontal reflection. And then the last piece that we have is our stretches and shrinks. You know, remembering that when we're multiplying by a whole number, outside is a vertical stretch, inside we have to do the opposite, so it's a horizontal shrink. And then when we multiply by a fraction, Outside is a vertical shrink. Inside, doing the opposite, flipping it to the reciprocal, is a horizontal stretch. Okay, good luck on today's homework.